Hi guys, my name is Noel Enrico Simabatid. So the assessment title for today is plot position lines to determine ship's position using terrestrial observation. So the scenario is at 14:30 hours, the vessel is at the vicinity of the southern part of Panay Island with rising tide and on course of 278 degrees true. Speed is 10 knots. The OW observed two lighthouses at the same time. The liberated lighthouse bears 090 degrees relative, while the Pushu Port lighthouse bears 030 degrees relative. After 40 minutes, Pushu lighthouse bears 060 degrees true. Distance 3.2 nautical miles, and the OW altered the course to 016 degrees true times 10 knots. At 15:54 hours, Nasong Port Lighthouse bears 030 degrees relative. After 30 minutes, Nasong Port Lighthouse bears 90 degrees relative. So, the first thing we need to do is to write the relative bearing of the lighthouses. So, we need to write the speed of the vessel. So, the speed of the vessel at 14:30 is 278 degrees true. So, by 10 knots. And then, we have the Libertad bearing, which is 90 degrees relative. So since it is relative, we need to add the 278 degrees true in order to get the Libertad true bearing. So 90 degrees relative bearing plus 278 degrees true is equals to 8 degrees true. So this will be the true bearing of Libertad Lighthouse. And the next is the Pushu Lighthouse. So the Pushu Lighthouse has 30 degrees relative. And again, since it is relative, we need to get the Pushu Lighthouse its true bearing. So 30 degrees relative plus 278 degrees true is equals to 308 degrees true bearing. So that will be the Pushu Port Lighthouse true bearing. So since we already got the two of the lighthouse true bearing, so we need to plot the two lighthouse. So the first lighthouse is the Libertad Lighthouse, is about 8 degrees true. So 8 degrees true. Eight degrees true. Libertad. So this is the 8 degrees true. So this is the Libertad Lighthouse. So 8 degrees. So all we need to do is just drag your triangular ruler to Libertad Lighthouse. Then make a line of position. The next one is the Pushu Port Lighthouse. So the Pushu Port Lighthouse is about 308 degrees true. So 308 degrees true. 308. This one. So the Pushu Port Lighthouse is here. So all we need to do is again drag your triangle ruler to Pushu Port Lighthouse. 308. Then drag to Pushu Port Lighthouse. This one. Then again make a line of position. Then write the corresponding true degrees. So at Libertad, it is 8 degrees true. And at Pushu Port is about 308 degrees true. So now, since we already plotted the two lighthouses, so now we can locate the true bearing of our ship, which is at 278 degrees true. So 278 degrees true. 278. This one, 278. Then again, drag your triangle ruler. Then draw a line. So this one is where our true bearing of our ship, which is 278 degrees true by 10 knots. So next is we need to determine the coordinates of a fixed position of 1430. So we need to get also the lat and the longitude at 1430. So this part will be our cross bearing. This one by 1430. So it says here that we need to determine also the coordinates of a fixed position of 1430. So this is our fixed position at 1430. Then now we need to get the latitude and the longitude of at 1430. So at 1430, this one. So it says here it is about 11 degrees and 45 minutes. So the lower part is 11 degrees and 45. So this will be 11 degrees and 44, 11 degrees and 43. Then so it is 11 degrees and 43.9 minutes. So the lat will be 11 degrees 43.9 minutes. So next one is the latitude. So say I am in the longitude. So since it says here it is about 122 degrees longitude, so it means here is 121 degrees. So get one. So it is a oh. So it's about 121 degrees 45 50 55. So 50 50 51 52 53 51 52 53 54 55. So 54.2.4. So it is about 54 54.5. So the longitude is 121 degrees 54.5 minutes. So next is it says here that at 40 minutes the Pushu Point Lighthouse, which is this one, has about 60 degrees true with a distance of 3.2 nautical miles. So again, this is the Pushu Point. So it's about 60 degrees true. So 60 degrees true. So again, all we need to do is to drag your triangle ruler. This one. Then locate to Pushu Point Lighthouse. This one. Then make a line of position. Then it says here that with a distance of 3.2 nautical miles. So 3.2 nautical miles. So from here is 11 degrees and 45 minutes. So it means that this one is by 1. So 46, 47, 48, 49, 50. Oh, then it says here it is 3.2 nautical miles. So 3.2. 1, 2, 3. This little line is 0.2. So 1, 2, 3.2. 3.2. This one. Then locate your Pushu Point Lighthouse. Then put a mark. So this one will be the Pushu Point Lighthouse at 60 degrees true by 3.2 nautical miles. Then the OOW altered the course at 16 degrees true by 10 knots. So altered the course by 10 knots at 16 degrees true. So 16 degrees, this one, 16 degrees true. Then again, drag your triangle ruler here, then make a line. So this is where your ship has been altered the course at 16 degrees by 10 knots. So course is 16 degrees true by 10 knots. Then the next one is at 15:54 hours, the Nasung Point Lighthouse bears 30 degrees relative. So since it is relative, we need to change it into a true bearing. So since our ship is at course at 16 degrees true, so the Nasung is about 30 degrees relative. Then our ship course is about 16 degrees true. So 30 plus 16 is equals to 46 degrees true bearing. So that means the Nasung Point Lighthouse now has a 46 degrees true bearing. So since we already got the Nasung Point its true bearing, which is 46 degrees true, so we need to find we need to find the Nasung Point. So this is the Nasung Point. Then we need to find the line of position of the Nasung Point, which is 46 degrees true. So 46 degrees true. This one. Then again, drag your triangle ruler to Nasung Point Lighthouse. Then make a line of position. So this one will be the Nasung Point Lighthouse at 15:54 hours by 46 degrees true. So the next is to plot the Nasung Point Lighthouse after 30 minutes. But it has 30 degrees relative. So since it is 30 minutes, so the Nasung Point will be 90 degrees relative. Plus our ship course at 16 degrees true bearing. So this one will be 106 degrees true course. So since it is 106 degrees true course, so all we need to do is to plot the 106 degrees true course to Nasung Point Lighthouse. So 106. This will be our 106. All you need to do again is to drag your triangle ruler to Nasung Point Lighthouse. Then make a line of position. So this will be the Nasug Point Lighthouse at 16:24 because it is after 30 minutes. So it is after 30 minutes of 15:54 hours, it is 16 and 24 hours at 106 degrees true. So since we already got the line of position after 30 minutes, this is will be our line of position at 16:24 hours after 13 minutes by 106 degrees true. So it says here that we need to find the 1510 hours combined in bearing and range. So we need to find the fixed position of the 1510 hours. So this will be our fixed position. We'll name it as fix. This one will be fix position at 1510 hours. The next is we need to find the 1510 hours, its latitude and longitude. So latitude and longitude of 15 hours. Fifteen ten. So the latitude, since it says here it is 11 degrees and 45 minutes, so below will be 46, the below will be 11 degrees and 44 minutes, 11 degrees and 43, and so on. So it says here that our latitude at 1510 is 11 degrees and 46.2 minutes. 11 degrees and 45.2 minutes. So that will be our latitude. And then for the longitude is for the longitude, so it says here it is 122. So it means here is 121. So 122. So 45, 45, 46, 47, 48, 49, and 50. So this will be this will be 121 degrees, 45, 46, 47.9 minutes. So the longitude of 1510 is 121 degrees and 47.9 minutes. Wait, 46, 47, yeah, 47.9 minutes. So now, we need to plot the dead reckoning at 1554 at the Nasug point. So, we need to make the distance run at 44 minutes. So, since this is the 1510 hours, which is our fixed position, and this one is at 1554. So 1554 minus 1510 hours will be 44 minutes. Then 44 minutes divided by 60 is equals to 0.73. So that will be our distance run. But we need also to know the 0.73 nautical miles. I mean the nautical miles of 0.73. So we need it to multiply by 10 knots because it says here is 10 knots. So 0.73 times 10 knots is equals to 7.3 nautical miles. So 7.3. So again, from here, so this one, this big one will be 1. So 1, 2, 3, 4, 5, 6, and 7. So it says here 7.3. So this small line is 0.2. So in between here. So 7.3. 7.3 and 2.3. Then from here, then put a mark. So this one, um, this one will be the distance run of 0.73 at 44 minutes. So it says here that we need to locate the dead reckoning position at 1554 at Nasug point. So this is our 1554 hours at Nasug point. So we need to plot the dead reckoning. This will be our dead reckoning. Now it says here the running fixed position at 1624. We need to transfer the first LOP of the dead reckoning position. So this is our first dead reckoning position. It says here that we had a 10 knots. So half of 10 knots is 5 knots. So 5 knots. 1, 2, 3, 4, 5. So from here, then put a mark. This will be our first LLP of the DR position at 1624 hours. So since we already got the 1554 at Nasug point, this one, the 1554 at Nasug point, and it has 46 degrees true bearing. So we need to transfer it to the after 30 minutes run of 5 nautical miles. So 46 degrees true. This one 46 is true. Then drag your triangular ruler where is your 5 nautical miles is located. This one. Then make a plan position. So now we already got um, a fixed position at 1624. This one we'll name it as should I put this here? RF R fix of 1624 hours. So lastly, we need to find the running fixed position, its latitude and longitude. So this one is our R R fix of 1624 hours or running fixed position at 1624 hours. So we need to find its latitude. So it says here that it is 11 degrees 11 degrees 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 54.6. So it is 11 degrees and 54.6 minutes, which is our latitude. And then for the longitude is says here that since it is 122 degrees, so it means that here is 121 degrees. So from there, so it says that our longitude is 121 degrees and exactly 50 minutes.